My dear students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the chapter Newton's laws of motion. This is part 9 of the video. This is the first problem. A frictionless cart of mass m carries two other frictionless carts having masses m1 and m2 connected by a string passing over a pulley as shown in figure. The horizontal force that must be applied to m, okay, so that m1 and m2 do not move relative to it will be, okay. Now in the previous video also we have done one problem of this type. For these kind of problems, first we have to observe from ground. Observation from ground. Observation from ground. Now if I observe this from ground, what is going to happen? This is चलाने वाला force, okay. F minus रोकने वाला, nothing is there, is equal to total mass. Total mass is how much? This is m plus of m1 plus m2, where the acceleration will be in the direction of force. This will be the acceleration. This will be a, okay, into a. Understood? Therefore, F is equal to m plus of m1 plus m2 into a. Now, we do not know a. We have to calculate a. How to calculate acceleration? We have to do what? Relative observation. Relative observation we have to do. Relative observation to calculate acceleration. Now, to do relative observation, what we have to do? We have to go and stand here. Okay, we have to go and stand here. If I observe this one, okay, what is A relative? A relative will be 0. A relative will be 0. Relative acceleration will be 0. Because if you are in the bus, you cannot see that bus is moving. If you are standing outside, you can see that bus is moving. Okay, in the same way, A relative is equal to 0. These two are in rest, okay, relatively rest with respect to this person, okay. Now this is m2g, this is m2g, and tension will be there here in the string. Tension will be there here, okay, in the string. Now where will be the pseudo force? Pseudo force, see the direction of a. Direction of a is like this, therefore pseudo force will be acting like this. This is m1 into a is pseudo force and m2 into a is pseudo force. Okay. m1a, m2a is pseudo force. Now if I observe this, if I take this as what? If I take this as system boundary, if I take this as system boundary, okay, this these two internal forces gets cancelled. Okay, these two internal forces gets cancelled. A relative is equal to 0. Therefore, I can equate the forces. Okay. Now here m1 a, m1 a. Okay, forces are balanced here. Forces are balanced because what? A relative is equal to 0. Since forces are balanced, because A relative is equal to 0, I can, okay, equate. This is चलाने वाला and रोकने वाला. This is m2g is equal to m1a. m1a is equal to m2g, or I can write a is equal to m2 by m1 into g. Hope you understood. In the, if you observe from ground, you are going to get what? Force. Okay. F is equal to what? Total mass into A. For relative observation, okay, you have to go and stand here. Okay. A relative is equal to 0. Since A relative is equal to 0, you can what? Balance the forces. How to balance the forces? These two forces gets cancelled, because if I take this as system boundary, okay, balance these two forces m1a and m2g. Okay, m1a is equal to m2g. These two forces I can what? Balance. Now a is equal to m2 by m1 into g. Now you substitute this one in f. F is equal to, this is the equation of horizontal force, m plus of m1 plus m2. In place of a, Just substitute this one. M2 by M1 into G. See which is the correct. M plus M1 plus M2. M2 by M1 into G. Yeah, this is the right option. Hope you understood this. We'll go to the next problem. Now, again, same type of problem. A hanging block of mass M dash. Mass M dash is there. Okay. Mass M dash. M dash is where? M dash is here. Okay. Prevents the smaller block of mass M. Okay, this mass M from slipping over a movable triangular block of mass M. This is the triangular block. Okay. Triangular block. Right. All the surface, all the surfaces are frictionless and the strings and pulleys are light. Okay. All the surfaces are what? All the surfaces are what? This is horizontal, vertical surfaces are frictionless and strings and the pulley are light. Value of mass M dash. Value of mass M dash in terms of M, capital M and theta is. Now, how to do this sum? How to do this sum? First of all, we know that for no relative slipping, for no relative slipping, what is A is equal to G tan theta. Where did we see this one? In case of if a triangle is there, okay, and if a block of mass M is kept here, let us say this is capital M, this is small m, okay. If the acceleration is like this, you apply force here. If the acceleration is like this, you apply force here. If the acceleration is like this, okay. Now this A is equal to what? G tan theta. For this block not to slip, okay. Now A is equal to G tan. This we have seen in the previous videos. One problem we have done. A is equal to G tan theta. Now here, if I observe this from ground, observation from ground, this you remember, okay. If the acceleration is towards right side, observation from ground, observation from ground. Now, see here, we are supposed to calculate the value of mass M dash, okay, which is hanging here, right? Observation from ground. If I observe this from ground, okay, now this is what? M dash G. This is weight. Okay? Tension will be there here and tension will be there here. Okay. Now, acceleration is towards right side here. Acceleration is towards right side. Now, if I take this as system boundary, okay, which is चलाने वाला is M dash G. रोकने वाला nothing is there is equal to total mass. How much total mass? M plus small m plus what? M dash. Okay. Into what? Into A. Into A. That is M dash G is equal to M plus M dash. How much is A? G tan theta. G tan theta. This triangular, this system is moving without what? Slipping. Without making this block M to slip. Therefore, A is equal to G tan theta. That's why for no relative slipping. Okay. Now, so what I can do? GG gets cancelled. We have to calculate M dash by tan theta. I can write that is equal to M plus of M dash. Now what is M dash? 1 by tan theta is cot theta. M dash cot theta is equal to M plus of M dash. Small m. Now I can take this M dash as common, and this M dash will be coming on the left hand side, that is equal to M plus of M. Now simplify for M dash will be equal to M plus of M, capital M plus small m divided by cot of theta minus 1. Understood? Capital M plus small m divided by, now which is the correct answer? Cot of theta. Okay, small m plus m divided by cot of theta. Okay, now I think this one they might have taken as m1. Okay, m1 they might have taken, therefore you can write. Hope you have understood this one. Okay, this is the right. Now in the previous sum, okay, we observed it from ground, we wrote what? F. Late observation we got A. Okay, because here what did we do? Since because here let u is equal to 0, forces are balanced. Forces are balanced. Forces are balanced. Here again, if we observe from ground, okay, we are simplifying for m dash. Hope you understood this. Already we know for no relative sweeping A is equal to g tan theta. Now let us go to the next problem. Hope you are understanding. Now this is the last problem of this type. Body A, okay, is placed on frictionless wedge making an angle theta, okay, with the horizontal. The horizontal acceleration towards left to impart it to the wedge for the body A to freely fall. It is moving to the left. Now we are supposed to apply forces on it. Okay, you know that mg will be what? Downwards. Mg will be downwards. Okay, this is perpendicular. This is what? If this is theta, this will be also theta. And this will be how much? This will be mg cos theta. This will be mg cos theta. Where mg sin theta will be? Mg sin theta will be here. Normal reaction will be same. Okay. Now, if I go and stand here, I feel like this is falling freely. Okay. Now, A is towards left side. Where is the pseudo force will be? Pseudo force will be on the right side. Okay. This will be what? MA. Okay. If this is theta, this will be also theta. Okay. Now, where is your MA cos theta will be? MA cos theta will be this side. This is MA, this is theta. MA cos theta, again it will be this side. MA cos theta. Where is MA sin theta will be? This side. MA sin theta will be this side. MA sin theta. Hope you understood, students. This is very, very important. Okay. Now let us once again I will explain you. If this is the block, where is mg cos theta? Mg cos theta is this side. Okay. Where is mg sin theta? Mg sin theta is this side. Where is MA? Okay, there are two components of mg. Now, MA is pseudo force. Where are the components of MA? One will be this side only. That is MA cos theta. Where is the other component of MA? This is MA sin theta. And this is perpendicular. Okay. Perpendicular to surface, this is normal reaction. Now, if this person sees here, okay, this is falling freely. Okay, this block is falling freely. Now, to make this fall free, I have to equate the perpendicular forces. Okay, which are the perpendicular forces? Mg cos theta will be equal to what? Mg cos theta will be equal to what? M a sin theta plus of n, because there are two forces here. Now normal reaction is equal to 0 this time. Why? Because it is falling freely. Therefore, I can equate these two. Mg cos theta is equal to what? Ma sin theta. From here I can cancel m and m. M will be equal to what? G cos theta by sin theta. That is equal to, m is equal to what? G. No, this is a is equal to. A is equal to what? Acceleration a is equal to what? A is equal to G cos theta by sin theta. Therefore, A is equal to what? G cot theta. A is equal to G cos theta by sin theta is cot theta. G cot theta. Students, hope you have understood all these problems. Okay, very important. Whenever you have a wedge like this, if this is the mass, okay, if this is moving like this, if this angle is theta, what is acceleration for no slipping? A is equal to G. Now here what is coming? A is equal to G cot theta. Now here the wedge is moving, okay, left side, and this is falling freely, okay. You are supposed the horizontal acceleration towards left to be imparted to the wedge for the body A to fall freely vertically is A is equal to G cot theta. Hope you understood these problems. If you like this video, kindly share with your friends, ask doubts in the comment box, subscribe for my channel and like the video. If you subscribe and if you ask doubts in the comment box, I'll be interested to put more and more videos for you, so that it will be helpful for your examinations. We'll be solving lot of problems inshallah on different chapters and on different topics, and I will come with interesting problems for you people. Okay, thanks for watching my video. I wish you all the best for your KCET, NEET and IIT JEE examinations.